So in this lesson, we want to learn about Pythagorean theorem. The purpose is when we have a right angle triangle and we have the measurement of two sides, we find the third one. How do we start? We first start by labeling the sides of a right angle triangle. First, we go ahead and we label the vertices. So capital C is always for the 90 degrees angle. And the side right opposite to it is going to be small c. The other two does not have to be specifically A or B. You can pick any letters for them. If you pick this one to be A, and that's one of the acute angles, it's going to be small a. The side right opposite to its side BC is going to be small a. And the side right opposite to B is going to be small b. Here's the Pythagorean theorem relationship. The hypotenuse, or the very long side, the longer side c to the power of 2 equals to side a to the power of 2 plus b to the power of 2, the other side to the power of 2. So we call A and B legs, and we call C the hypotenuse. So hypotenuse to the power of 2 is A to the power of 2 plus B to the power of 2. Let's do two examples. If in a right angle triangle we have the measurement of the two legs, how do we find the measurement of the other side? Very first step, let's label it. Capital C, small c. Doesn't matter which one's A or B anyways. But okay, B and B. We always start with labeling. We write down the formula. C2 is A2 plus B2. We start looking for the values. C is the one which is missing. We do not know how much C is. That's the one we want to find. But we do know how much the other two sides are. So I just go ahead and plug in their values. A is 4. So A to the power of 2 is 4 to the power of 2, which is 16. B is 3. So B to the power of 2 is 3 to the power of 2, which is 9. So if I add them based on the formula, I have to get C2. So c to the power of 2 is 16 plus 9, which is 25. So c equals to square root of 25. What is the square root of 25? 5. So we realize that side C is 5. So we found that. Let's do one more example. What if in my right triangle, I know that one of the sides is 6, the other one's 8, and I do not know the hypotenuse? Where do we start from? Labeling. So my question mark is C, and these sides, one of them is a small a, one of them is a small b. You don't have to label the vertices, but if you do, that's even better. So C2 equals to A2 plus B2. This relationship is called the Pythagorean theorem, and we need to memorize it. Okay, the hypotenuse, or the longest side, is missing. So I'll go ahead and plug in the values. So 6 to the power of 2 plus 8 to the power of 2. What is 6 to the power of 2? 36. How about 8 to the power of 2? 64. That's our C2, okay? Let's add them together. 100. C2 is 100. C to the power of 2 is 100. So C equals to square root of 100. That equals to a 10. So C is 10. There we go. We found it. Third example. Now I want to change it a little bit. I'm going to draw a right angle triangle. And over here, I'm going to tell you that I have a 15 here and a 9 here. And one of the legs is missing. Let's go ahead and label them. We always start to label with the hypotenuse. So which one's the hypotenuse? The longest side, or the side which is right opposite to the 90 degree. So C is going to be 15. Okay, let's call 9A. Now B is missing. One of the legs is missing. So the difference between this question and the other two is that in these two, the hypotenuse was missing, but now here, one of the legs is missing. I'm going to write down still the formula, 2 plus B2, and I'll plug in the values. We do have C, so we're going to write down 15 to the power of 2. We do have A, 9 to the power of 2, plus B2. Next step, let's calculate them. Whenever we're stuck, we do what we can do. What is 15 times 15? 225. So 15 to the power of 2 is 15 times 15. What is 9 to the power of 2? 9 times 9, 81, plus B2. Next step, what is next step? 225 minus 81 equals to B2. I do a subtraction. 225 minus 81 is 144. That equals to B2. Now how do I find B? So B equals to square root of 144. So B equals to 12. Yay, we found it. This is how we find one missing side in a right-angled triangle.